Hey guys, welcome to our notes on relative dating. No, not that type of relative dating, just kidding. Alright, but relative dating with rocks. Okay, so we're going to figure out the age of rocks compared to one another. So just to show you guys, so obviously you'll be comparing rock layers in age. Sometimes it's a single rock unit like this, or sometimes like this where you look at multiple locations and be able to figure out their ages compared. Alright, so we'll look at different techniques and how this works and how to actually put rocks in age order and sequence order. Okay, so relative dating is putting rock layers sequence order, which came first, second, third, etc. We start our way with the oldest and then work our way to the youngest event. It's just an easier way to go about things usually. But in order to relatively date rocks, we have to follow a bunch of rules. So looking at number one, the law of superposition. This basically says that the oldest is on the bottom, youngest on top. Because sedimentary rocks, sediments will be placed on top in order where the oldest is going to be on the bottom, youngest on top. And same thing with lava flows that kind of happen. So each overlying layer is going to be younger, so that the top layer ends up being the youngest event. Okay, and then we have to also assume original horizontality. Okay, sedimentary rocks, lava flows are originally deposited in horizontal layers first. All right, and then crustal movements, as we know them, happen afterwards. So that will help us to sequence things better. Igneous intrusions and extrusions. So contact metamorphism tells us the story of whether the rock is going to be younger than the material it's touching or not. So if you see those contact metamorphism lines, the magma or lava is partially melted. I know we're burned here, but partially melted and ends up changing the rock, and therefore that rock that it changed had to be there first for that to happen. So an intrusion is going to be younger than any rock layers it cuts through. And again, you have to look for those contact metamorphism points, the Hatcher lines that are touching the other rock layers. Extrusion or a lava flow is younger than the rocks below it, but older than any rocks above it. All right, because an extrusion comes to the surface, makes a horizontal layer, usually called a sill, and then on top of it we'll have other layers that get deposited later on. Fold. Okay, the rock layers have to be there to be folded. Okay, so the rock is older than the folding. Sometimes the folding can actually overturn the rock layers that the older rock layers lay on top of younger rock layers. That can happen, so that's an extreme fold that happens from a lot of crustal movement. All right, and that can throw the order out of whack a little bit, so that can make it a little challenging. Also faults, the rock layers are older than the fault, because once again the fault is going to happen after they were deposited. And sometimes, again, once again, just like the fold, the faulting can be so extreme that you can actually push older rock layers on top of younger rock layers. Okay, and the last, this seems like a silly notion or a silly rule, but the sediment in the sedimentary rock is older than the rock, right? That's the oldest part of the rock material, because the sediments have to be in existence first, and then the sedimentary rock formed later on. Okay, so order of events, when you do these, we start from the oldest, work our way to the surface. So let's do a couple of these together. I'm going to do them over at the board. So the first one, number one, ends up being the oldest is on the bottom, youngest on top. So what we're looking at here on this one, so starting with number one, going by the symbols on the bottom, which are also on the reference table, just so you guys know, on the sedimentary and metamorphic rocks. But number one is limestone, it's on the bottom. 2 is going to be sandstone. 3 is going to be shale. And lastly, number 4, all these layers were folded. So the folding is the last event, youngest event of this sequence. Okay, so next, number 2, same thing, same order. So 1 is limestone as the oldest event. 2 is going to be sandstone. 3 is going to be shale. And 4 is faulting of the layers. All right, because you can see the offset here. This dropped down, this went up. So that clearly is a fault. Okay, igneous intrusions and extrusions. So an intrusion is going to be younger than all the rock layers it touches, because these little contact metamorphism lines, all right, so you can see them here, pointed out with the blue line. So if you see contact metamorphism, it's going to be younger than any layer it touches. So once again, 1 is limestone, 2 is going to be sandstone, 3 is going to be shale, 4 is going to be your igneous, and this is not an intrusion. It would be if it stopped at a certain point, but this is an extrusion because it comes out of a volcano. Alrighty, so that's that one. Alright, this sequence you can use letters, so you can pause it and try this before you move on. Alright, but I'm going to go through it right now. So number 1, the oldest layer is going to be B. 2 is going to be W. 3 is going to be E. 4 is going to be the faulting of B, W, and E. Okay, 5 is going to be the erosion of E, right? You can see that clearly. It basically got taken off on the one side. You can see it's very small on this side. 6 is going to be K. And then 7, we could even go further and say erosion of K. Alright, that's our final event. Okay, so again, it's a little puzzling. You guys got to figure it out. Alright, and I have 2 more that are definitely a little more difficult. Okay, so once again, you could pause it and try them on your own. Okay, so the first one, okay, start from the bottom, work your way to the top. So 1 is F. Okay, 2 is going to be E. Now, tricky, this one is actually an extrusion, so 3 is going to be D. All right, you can see contact metamorphism lines are only facing on the down side of it. 4 is going to be C. We could also, I didn't realize too, I could throw erosion in here as number 4. I'm going to stop and do that for a moment. So erosion of D actually. All right, and then we'll go C. Then 6 is going to be B. 7 is going to be A. And then lastly, number 8 is erosion of A. All right, and then down the bottom, a little more fairly complex one. All right, so starting from the bottom again. Whoop, sorry about that. Okay, number 1 is going to be I. 2 is going to be B. 3 is going to be F. And then, next one is going to be fault. FBI. I think someone was trying to be funny on that one. Number 5 is going to be the erosion of F. Okay, number 6 is M. 7 is going to be R. And then 8 is intrusion H. All right, you can see it goes into there. Contact metamorphism lines all the way around it. And then lastly, if we want to go 9, erosion of R. That's That's a good way to end it. Okay, so those are definitely a little challenging at first. You got to take your time and think those through. All right. Also, an important thing in this chapter is unconformities. Okay, so when we're dealing with rock units, especially in one little area, we can have what's called unconformities. So what are they? What they are is a long gap in the rock record, because remember, things happen slow in geology. So rock layers that have been destroyed or no longer present are unconformities. So unconformities represent large gaps in time order because they have to follow these 5 steps to happen. Okay, so first off, sediments will be deposited somewhere, okay, such as the ocean or a lake, and get compacted and cemented to form rocks. All right, and again, this takes millions of years to happen. So you notice on the bottom we have shale and sandstone here, okay, which are harmonious on the bottom of the ocean, okay, for now. All right, and let's see what happens. All right, moving on, sedimentary rocks are uplifted, okay, some sort of crustal movement. They end up emerging out of the ocean, and again, millions of years for this to happen. Shale and sandstone are now exposed on the surface. Okay, then agents of weathering and erosion break down the rocks, and the erosion actually end up removing them. And again, millions of years of this, and you notice sandstone's all alone now because shale got eroded away. Okay, so sandstone's all lonely here. And then sometimes the sandstone will go back down into the ocean because subsiding or crustal movements once again. And again, millions of years of this taking to get back down to the bottom of the ocean. And then new sediments are deposited on top of that old erosional surface and form into new rock layers. And again, millions of years of forming conglomerates, limestone are now new friends to the sandstone here, end up on top of it. However, the shale that was once here now is erased from existence. All right, so basically you have a buried erosional surface with a little gap in the rock record. Sometimes this is shown with fossils, all right, but this is a way that this can happen and rock layers can be erased from existence. Okay, and then here's an example of one with 2 rock units, comparing them from place to place. You match up index fossils like 3 and 3, 4 and 4. Okay, and then you get up here, here's number 6, 6, and then this one, 5, which is in between the 4 and 6, does not show up on this one. So you can see right here, this squiggly line, that represents the unconformity. All right, so that's an area that got eroded away, erased from existence, and again, weathering and erosion are the culprit here. All right, and then 7 and 8, and then 7 and 8 didn't get deposited here for some reason. That does happen also. All right, but basically, that's what happens with the rock records, and that's why you end up having incomplete rock records in many places. Okay, and one more thing before we go, I just want to show you. I also made this for intrusion to extrusion. Okay, so basically intrusions, so just to show you an example here, so A, B, C, D. All right, D is an intrusion here that you see the contact metamorphism line touches all 3 layers. So D is going to be younger than all 3 of these layers. In this example, the extrusion D is going to be younger than A and B, but older than C. All right, and why do you know that? You see these contact metamorphism lines? They stay on the bottom side of D, okay? Not touching C in any way. So C actually is a younger event, and this was an extrusion that came to the surface, and you can clearly see that. Sometimes they'll show erosional lines on top of this, sometimes they won't. They just won't show the contact metamorphism lines. But either way, make sure you understand the difference between those two. You'll definitely see it from question to question. All right, thank you guys for tuning in, and keep these rules in mind, and I'll see you guys next time.